Hey guys, Mr. Backerberg here. In this video, we're going to take a look at the rational zeros theorem. So what the rational zero theorem says is that if we're dealing with a polynomial function f, where the degree is 1 or higher, then we can find some potential rational zeros of the form x equals p over r. And those p values are going to come from the integer factors of your constant term, so the term that doesn't have any x's in it, and your r values are going to come from integer factors from your leading coefficient, so the coefficient on the highest powered x within your function. So we're going to take a look at the function f of x equals 3x cubed plus 4x squared minus 5x minus 2, and we're going to try to find some rational zeros by using our rational zero test. So we want to come up with p and r values by taking a look at our function. Those p values are going to come from the factors of the constant term on the back end, so we would want to think about things that would multiply together to give us negative 2. So we could multiply a positive 1 together with a negative 2, or we could multiply a negative 1 together with a positive 2. So I'm going to write these both as plus or minus in there. So those are our potential p values on top. Now, as far as those r values, we want to look at the leading coefficient, so multiply into 3. So that'd be 1 and 3 or negative 1 and negative 3. So again, I'm going to write these with the plus and the minus on them, because if I took positive 1 times positive 3, that would give me 3. But if I took negative 1 times negative 3, that would also give me 3. Now, what I want to do with these is I actually want to break them up into fractions or integer values. So what I want to think about doing is taking this 1 and dividing it by the 1. Well, 1 divided by 1 is just 1, but I'm going to keep the plus or the minus on there, because we could have positive 1 or we could have negative 1, depending on how we arrange the signs as we're building these fractions. Now, if I took the 2 and put it over the 1, 2 divided by 1 is 2, but again, I'm going to put the plus and the minus back on there, because we could end up with a positive 2 or a negative 2, depending on how we're choosing our signs. Then I'm going to take the 1 over the 3, so I would have positive or negative 1/3. And then I'm going to take the 2 over the 3, so I would have positive or negative 2/3. So as I'm looking at this list in here, I have 8 potential rational zeros. So what I want to do to see which ones work is I'm actually going to run some synthetic division. So inside of your synthetic division bracket, remember we put the coefficients from our polynomial in there. And then all I'm going to do is I'm going to guess a number off of my list, and I'm going to do the synthetic division to see if it works. So let's say I wanted to test out 1. What I would do is I would drop the 3 down. I would take 3 times 1 to get 3. I would add the 4 and the 3 to get 7. 7 times 1 is 7. I'm going to add up the negative 5 and the 7 to get 2. And 1 times 2 gives me 2. And I get 0 as my remainder. Now remember, getting 0 as a remainder is a good thing, because that means that this number that you were dividing by is a 0 of the function. So we know that x equals 1 is a 0 of this function. And because x equals 1 is a 0, that means that x minus 1 would be a factor of the polynomial. Now I want to test out some more values. So what I'm going to do is I'm just going to continue off of this, and I'm going to do another round of synthetic division. And let's say this time I wanted to pick negative 2. Okay, I'm just guessing a number off of my list, and I'm going to do the synthetic division to see if it works. So I would drop down the 3. 3 times negative 2 is negative 6. Add these together, we'll get 1. 1 times negative 2 is negative 2. So that gives me a 0 remainder again. So that tells me that x equals negative 2 is also a 0 of my polynomial, which means that x plus 2 would be a factor of my polynomial. Now there's actually one more rational zero in here, so I'm going to do one more round of synthetic division on here, and my next number that I'm going to choose is negative 1/3. Again, I'm just guessing a number off of my list, and we're going to test it out to see if it works. So I drop down the 3. Negative 1/3 times 3 is negative 1. I get 0 as my remainder, which tells me that x equals negative 1/3 is a 0 of my function. Now, if I was going to try to find the factor with this, I would need to treat it just a little bit differently. What I would have to actually do is multiply this 3 over to the other side first. So I would get 3x equals -1, but then I would have to add that 1 over, so I would get 3x plus 1 as that last factor. And because this is a cubic function, we can have at most 3 factors and at most 3 zeros in there. Now, we're not always going to be able to guess the numbers right away, but what we're looking for is getting zeros as the remainder in there. If you test something out and you don't get 0 as a remainder, then that means that that number is not a 0 of your original function. So you would want to just keep guessing values off of your list and doing that synthetic division until you get those zeros as your remainder. That's going to be it for this video. Thanks for watching.